Hi everyone, in this video I'll be discussing how to set the weather properties in HAP, but before that I'll quickly talk about these tabs on the left and when do you need to use each and every one. If you want to calculate the cooling and heating load only, you basically just need to set up the schedules, walls, roofs, windows, doors and shades. Any tabs after that, these are used to calculate the fuel and electricity prices and consumption. Also, if you want to calculate only the cooling and heating load, you need also to set up the weather, spaces, systems, and sometimes the plants. The plants tab, you use it when you have a boiler or chiller in the building. And the last tab, buildings, you use it if you want to calculate the electricity and fuel consumption and prices. So I'll be throughout the videos, I'll be going through each and every tab to calculate the cooling and heating load. So the first tab is the weather properties. To set that, you need to double click the weather tab, and the first thing you see is the region. This is basically the continent in which the building is. For example, if we choose Europe, and then the next tab is the location, and this is basically the country which the building is. For example, let's choose Ireland. So yeah, and last tab is the city, Dublin. And then the software will fill in automatically these values from the latitude until the winter wet pulp from ASHRAE 2001 handbook. It will automatically fill in these tabs. But if you feel like the 2001 the values are old, you can also go to the ASHRAE website and get the newest numbers. So for example, if you go to ASHRAE meto.info, you will get this map, and you have to go to the region you want the region the building is. So if we went to Ireland, Dublin, and we chose this area which the building will be in, we basically have to right click on the exact location, and it will give us the nearest stations that we can get our values from. So the nearest one, as you can see here, is 12 kilometers away. So if you click on that, you will get the tables down here that you get your values from. So the latitude, longitude, and elevation values, you can get it from here, these three. And for the summer design pulp and wet pulp, you can get it from this table right here, depending on the percentage that you want your cooling and heating system to cover throughout the year. So for example, if you choose the 1%, your system basically will cover 99% of the hours in the year. And this is the dry pulp, and this is the wet pulp values. And the winter design pulp, you can get it from this table right here. Again, by choosing the percentage, you will get the value that you need to fill in the tab. The last value, which is winter coincident wet pulp, this is only used for the condensations calculations in the building. So this value is not really important in the cooling and heating calculations. One more thing I forgot to mention is that you can choose the unit that you want, SI or IP, depending on which units are you using in your calculations. So the next tab is the atmospheric clearness number. This tab basically represents how clear the sky is. So if the sky is very clear, you can change and increase this number to, for example, 1.2. This number means that the radiation coming from the sun will increase by 20%. On the other hand, if the sky is not clear at all, you have a lot of clouds, you have a lot of dust, smoke, you can also decrease this number to lower than 1, for example, 0.8. And if you have no idea how clear the sky will be, you can always just leave it at 1. Or if you go to HARI HVAC application PDF file, you can see this map on chapter 35. You can get this map. This map, unfortunately, I could only find this map, which is only for the US. And you can get the exact value from these lines. These will show you how much the sky is clear. So depending on the location of the building. So the next step is the average ground reflectance, and this value represents how much radiation are reflected from the ground and hitting the building and will hit the building. And to get this value, you basically have to go to HARI Fundamentals PDF to chapter 31. You will get this table, and depending on the incident angle and the type of ground surrounding the building, you will get the exact value that you need to fill in the tab. The third tab is the soil conductivity. This value also, you can go to the same PDF, the fundamental one, and you should go to chapter 26. And depending on the soil type, you can get the exact value that you need to use. And an important note to know that you only use this when the building or the zone that you are calculating the heating and cooling loads are exactly above the ground. So the next step is the design calculation period. So basically, if you want to calculate the heating and cooling load for only 2 months, for example, or 3 months, you can always change it depending on which months are you trying to calculate the heating and cooling in. Or if you want to just leave it from January to December, it will calculate the annual cooling and heating loads. The next tab is for the time zone. This is the time zone of the building location. So the last tab is the daylight saving time, and you use this when the country that the building is in uses 2 different times for the winter and the summer. And if they do, you just press yes, and you specify when they do change the times and at what day the time will come back to normal. And this, by doing that, basically you are done now, and the weather properties are set. And if you go to the top, the next 2 tabs are just basically to show you the design temperatures during each month, the maximum and the minimum, and this one to show you the design solar heat gains for each month. This tab is only used when you need to calculate the fuel and electricity consumptions and prices. So thank you very much, and in the next videos I will go through the tabs right here one by one, each in separate video. And if you have any questions on the weather properties, please leave it in the comments. Thank you very much.